Okay, so this is going to be part two. In the previous video, we kind of built everything you see here. Now we're just trying to improve on it. So we ended off talking about the direction of those triangles because they're not really working the way we expect them to or the way we want them to. Um, so let's start off with that. Okay, so this is what we had before. One of the issues that's coming up here is that I am rotating the triangles by this final position vector's direction. But this final position vector, I'm adding on, it's both a directional vector as well as a displacement vector. So once I because I this gives me the direction right here, and then I add on this displacement vector, the final position of that vector is actually not the position, isn't the direction that I want it to be. So to get that started, or to fix that, I'll create a vector here, or a variable here, and I'll call it e vector, and I'll just copy all of that. So what I'm trying to do here is this final position is what I'm going to use for my line, but for my direction I'm going to use e vector. And as you can see, nothing has changed. To kind of summarize what's going on here, just with these two lines, you can think of each one of my variables is physically stored like in my RAM or whatever. Like there's a place in there that the data in this variable is stored in. So when I create this vector here for the e vector, that's going to be stored somewhere. But on the next line, when I say that the final position equals e vector, that's not gonna copy what's in that what's stored in that location and put it somewhere else. That's actually gonna point to the exact same location in my RAM as the previous variable. So then when I edit it in the next line and add this on, it's gonna take what's stored in that location and add to it. So my e vector is gonna change even though I'm trying to only do it to my final position. I hope you could follow that. The solution to this is not that complicated actually. I can just use this copy function. So this is gonna make a copy of this variable and store it somewhere else. And that's the first step in kind of solving the issues that I'm seeing. So now I have this e vector here, and I have all of this going on. So now what I need to do would be, I actually need to redraw this triangle. So before, I think I started on the bottom left and I went around it like counterclockwise, but now I'm gonna start on the right side. So I'm gonna start at like 0, 0, and then I'm gonna go to -10, -5. And from here I will go to -10, 5, and I think that makes a complete triangle. And is that working now? Let's see. Does it look right? I think that should be working. Let me bring this to 0 here. That all looks good to me. Yeah. Of course, now we have another problem, which is you can see if I have this up here and this is just a 0 charge, it kind of throws you off to see all of these triangles here, even though like the electric field is really weak here. So what I'm going to do from here is I'm going to apply like a scale to everything so that the size of the triangle will get smaller as I'm further out. And so to do that, I will create another variable, which I will call, I'll just call it scale. And I'll set scale equal to the magnitude of this vector. And then I'll use the scale to adjust the size of my triangles. So I'm going to multiply that by scale. I'll multiply kind of all of these by scale. Now you can see these are really huge because my vector is pretty big. So now if I just divide it by something, now you can see I kind of have these up here and these are way smaller down here. That looks okay. Maybe I'll reduce this some to, yeah, something like that. Maybe a bit more. Okay, that might be too much. Okay, yeah, 50 is good. So now I'm scaling the triangles, but I'm not scaling the lines. So let me also get to that. So for my lines, I will adjust the stroke weight. So that's the line thickness. Let's see what that looks like. Okay. I'll maybe increase that a little, maybe a little more. Okay. I have something that looks more promising now. This is one of the things that like you kind of play around with until you get something you're happy with. But yeah, I think I'm happy with what this looks like right now, even though it's not exactly what it looks like in the simulation. The overall point comes across. I think the last thing I'm gonna do here is gonna be, you can see like right there's this craziness going on with the point in which I'm drawing this specific vector here is very close to the circle. So it looks like it can be confusing, especially to students who are just learning about this, to see this kind of stuff going on, because if I do something like that, it might look like something is going to be pushed away from this charge, even though like in reality it's being pushed into the charge. So a quick solution to that, and I think I did that here, would be I'm only drawing these vectors if they're a certain distance away from all of my charges. And that just kind of helps get rid of some misconceptions, I think. So to do that, this is something you can try actually. I'm gonna do it because I have like a few minutes left in the video, but pause this and try and do it for yourself. That's the best way to learn all this. But if I was to do that, what I would do is I would just stick an if statement on everything. I will say, so I have this point. So I'll create a variable called draw, and I'll set, well, not draw, I think that's the name of there's like a draw function, so that might be weird. I'll call it draw vector, and I'll set that equal to true. And then I'll have a for loop that goes through all of my charges. That should just be an I, and then this is going to be my charges. And then I'm going to check the distance from each one of my charges to my point. So I can just use like, let's see. So let distance equal p5.vector.dist for distance, and I'm going to check the distance between the specific charge position and my point. And then I will have an if statement, and I will say if the distance is less than, I'll go with charge diameter, or did I just call it diameter? Let me check. Yeah, I just have it as diameter. So if the distance is less than the diameter, I'm gonna say that draw vector equals false. and then I'll just have another if statement here, and I will say if I'm going to be drawing the vector, then do everything in here, and if not, I will, like, it's just not going to do anything. So let's see what that looks like. Okay, yeah, so you can kind of see is if once I get close enough to a point, it no longer draws it, which gets rid of those like huge spikes and like those huge vectors that were kind of popping up. Anyway, I think we're more or less done with this. So in the next video, we will get into drawing field lines, which are, these are the field lines, which might seem complicated, but kind of like everything else. I mean, we've already built up the foundation for a lot of this, so it might be like a couple, maybe 2 or 3 videos before we finish everything, like before we get a result that looks like this. But yeah, I will see you in the next video.